Hello, welcome back to Blender Sushi Live Noding. In this episode, I want to do another improv video using Spreadshock nodes. And today I will be using Hilbert. So Hilbert, there's a Hilbert 2D and Hilbert 3D. For today, I will be using just Hilbert 2D. So by default, it actually creates line. And let me save this as Hilbert improv. So you might notice I'm using Blender 2.81 beta. I think this is actually more stable for me because I'm using macOS Catalina beta as well. So the next thing I want to create is offset line. So if you want to preview the result, there is actually a VD experimental. This is a viewer draw experimental nodes that's allowing you to see the result before you actually commit to the mesh viewer, the actual mesh result. So this is actually can be handy. So we use this a lot on Blender 2.79, but now we have it here. So this is the result. This is the bake. This is what we have, like a preview, and we can always bake it if you want to work like that, just to let you know. So with this guy over here, it's just a single, it's a polygon edge only. So I will put offset line over here, plug the edges, and get the output over there. Okay, so that's really handy. So what we gonna do next? That's nice, but what else can we do? We can perhaps randomize it, but I'm not gonna do that for now. I will be using adaptive polygons. So adaptive polygons, you have seen it before. It's pretty much like tissue add-on of Alessandro Zomparelli. It's recently got updated, and this is super handy to place pattern on a 3D object, on a face of a 3D object. So for example, we can use the cricket. Okay, actually, oh, they get rid of it. Okay, let's use Suzanne then. We can use Suzanne and just put it here. And let's try vmesh. I think the output's gonna be a lot of face. Oh, all right. Whoops, it crashes. It's okay, I'll reopen. Maybe, I think I did save it. So file, open, recent, Hilbert. So I'm up to here. Maybe generating, maybe I just found a bug or something. Oh, it could be like creating object with the same name, maybe. So let's merge this. Try Hilbert as adaptive polygons. This is gonna be the donor. And for the recipient, let's, instead of using Suzanne, let's use icosphere for now. I think adaptive polygon works really well with triangle, but also works with quad. Ah, yeah, there you go. It does look like some kind of Christmas decorations. Let's hide this guy over here. And you can at any time in points randomize the each and every face that we put in here. So I have a feeling the Hilbert should be, so let's use the viewer draw once again. VD, still experimental. And let's use the vertices and, oh, I want to see the edges. Maybe just the face, but I want to see just the icosphere. Okay. So adaptive polygon supposedly put our Hilbert on top of our triangle. My feeling is that the Hilbert needs to be centered. That's why it's looking kind of weird at the moment. So in order to center the Hilbert, I need to use vector drop. So perhaps this will work better. Okay, still looking kind of weird. Maybe Hilberts need to have some kind of thickness. Let me check our result over here. Let's hide this. So this thing is in this center. Maybe I should try, instead of icosphere, let's try grid. So polygon grid for now. Vertices, polygon, and result. Alright, so yeah, that's looking kind of weird because it's not flat that I was expecting, even though I already used vector drop. Maybe I did something wrong. It could also be a bug actually. Let me try. Remove merge. Okay, it's still the same. Merge it. Oh, because this guy is hexagon, that's why. Maybe I need to use triangle or square. Square, I think square, even square needs to be more flat. Maybe let's try using plane MK2. Plug this into this guy. And the same. So that's a normal plane, and our Hilbert is supposedly flat on the ground. Alright, that's pretty interesting. I have a feeling that if I add solidify or something, it's gonna be different. Let me try. I just bake this guy over here, right? From here, I bake it, and I will use objects in, get selection, get our Hilbert, and plug this into adaptive polygons. So we are not getting anything. Let me hit apply, get selection. Okay, now we actually have something. The coefficient is kind of like the thickness. So this is what I was expecting, but interesting interesting bug nevertheless. I'll have to report this. So this is Hilbert. If we use plane and adaptive polygon, so supposedly we can use this with Suzanne, or let me try this with icosphere for now. Subdivision 1, just in case. So yeah, that's probably better, and we can randomize our height. I thought this is kind of cool and can be handy for some kind of design. It doesn't need to be Hilbert, it can be any shapes. But here, like this, is looking quite nice because of Hilbert. But the problem is, of course, I don't know why it's got angle. Maybe somewhere in the process I need to kind of apply the matrix so it doesn't create angle. But something to report. There you go. This is basically it. If you want to maybe randomize further, what else can we do? Here we are randomizing the z coefficient, or the donor scale can be scaled if you like. Oh, there's a limit to 0.5, but you can go higher. If you go higher, that's a little bit random. But something like this, you know, these days you can just turn it into sculpt, and then you can always remesh, voxel remesh. That will actually create something that can be printed. It's really quite abstract, but when you're dealing with voxel and you're designing the 3D pore, this thing should work. Oh, this thing seems to be a bit complex. Normally it takes like a few seconds, but I guess you got the idea. I don't need to wait. Oh yeah, there you go. That's completed. Everything is a single mesh now. If you look at the wireframe, it looks crazy detailed, but they are not overlapping. They're actually creating a volume. So that's a, yeah, maybe I just keep it. File, save as. All right, so hopefully you find this interesting. So instead of using Hilbert, I was gonna try grease pencil demonstrating random pattern, but maybe that's for the next video. All right, thanks again for tuning in, and I'll see you next time. Thank you. Bye.